is nothing more than review from Algebra 2, except for what's called a slant asymptote. Yes, you can have asymptotes that are on diagonals. We're going to figure out how to find those things here. All right? So let's just get started into rationals. Rationals were this stuff. If you guys remember from last year, there was this nasty page in the Algebra 2 book that looked like, which one was it? There was this page in the Algebra 2 book that all this, where was it? Did I skip it? Information about asymptotes and all that other junk. Remember this stuff from last year?
Yeah.
It's basically it's the exact same thing as what we did last year with the rational functions, with this whole chart, but it's just written a little bit differently in the pre-calc book. So that's what's going to be different. So when we dealt with the rational functions, we're basically looking at functions that are just fractions. One of the degrees can be different from the bottom, top degree can be different from the bottom degree. Then you had different places for asymptotes. Everything was written where you had to figure out x-intercepts and all that stuff for the graphs. Well, it still follows the same rules, it's just written a little bit different. So if you recall from last year, whenever you have a rational expression, the zeros of the numerator are the x-intercepts. The zeros of the denominator are the vertical asymptotes. And then you had that game where you're trying to figure out the horizontal asymptotes, whether or not your degrees were greater in the numerator or the denominator. And that's what told you where your horizontal asymptote would wind up, whether it was at 0 or the leading term coefficients, or there was no horizontal asymptote. It's all the exact same stuff. It's just written very, very similar. So they go through the whole idea of vertical asymptotes as talking about in terms of infinity. And what happens here is this. If you look at the graph of 1 over x, if we look at the graph f of x, what can't x be? 0. Can't be 0 because can you divide by 0? No. So when you're looking at this, you get that vertical asymptote at 0. Now the graph itself depends on how it's curving around. There's going to be curves here. When we first graph stuff, we always made tables. We did stuff like that. So if x is -2, what's f of x? -1, it's 0 is undefined, and then it's 1, and then 1/2. Now, to throw in another one in here, what if we put it at -1.5? Or excuse me, -1/2? What would that be? -2. It'd be at -2. And if it was at 1/2, it would be at +2. Because it's 1 divided by 1/2, so it's flipping it. So what happens here, you probably don't remember doing it like that, is that you're able to pick very easy points to work with to show what the curve is doing. -2, we were at -1/2. -1 at 1. And then notice what happened when we switched it to -1/2. We were at 2. We were getting this curve to do this. Do you guys vaguely remember looking at that? And it was kind of a mirrored image coming on the other way. It was doing that. That's what your rationals did. You had all these little bits and pieces. What the pre-calc book is going to have you guys do that's a little bit different than the Algebra 2 is that you're going to look at finding values that are going to be easy to work with apply. you're going to be creating your own tables with numbers that make sense. Okay? It's really, really simple. But all those rules still hold true. So let's make sure that we have these rules down. And what this is basically, P of x and Q of x, those are just some function. Okay? It's just some function. When they write it in terms of all that other junk, all this other junk here, that just means descending order. That's it. X squared plus 2x plus 6. It's in descending order. That's all that means. Oh, x squared plus 2x plus 6. It's in descending order. That's what I meant. All right. You can have holes in it where it can be x cubed x plus 4. It just has a 0x squared value. That's all. Excuse me. It's just showing that it's written in a descending order. That's all that those other numbers mean. So again, when we're trying to figure out what our x-intercepts are going to be, the x-intercepts are always the zeros of the numerator. The vertical asymptotes are always the zeros of the denominator. That.
Like what you just said.
The x-intercepts,
Yeah, can you write it down?
it's written right there.
Okay, but that's confusing.
Okay, so if we have an example, f of x equals x plus 2 over x squared minus 5x plus 6. That factors, right? Negative 3, negative 2? Okay. Yeah. My math checks out. So we'll use that as an example. We'll bounce back and forth off of this list then. I'm going back to it. Relax. We have to let Devin see something. Say hi to Devin.
Hi, Devin. Oh, I was the only one.
Hey, Devin.
He's recording.
I was sleeping.
Wait, what a person?
Hi back.
Oh.
Wait, will she see that you like use that?
She'll see it's the board. Like, switch out. Maybe.
You see everything. All you see is what's on the board. You don't see. Yeah. So when you're doing these things, we kind of do this in a real easy manner. First thing I would do is identify my x-intercepts would be at the zeros of the numerator. So I set the numerator equal to 0 and I solve for x. So where's my x-intercept? Negative 2. The second thing I would do is find the 0 of the denominator, or which would be my vertical asymptotes. Set that equal to 0, which means I have to factor. So what times what was positive 6? You add together to get negative 5. Negative 3, negative 2. Which gives me zeros at 3 and 2. Good. So as we're starting to look at the curves of these things and what these are going to look like, we know we have an x-intercept at negative 2. We have vertical asymptotes at 3 and at 2. And then the last little bit that was on there was talking about the horizontal asymptotes. Horizontal asymptotes are found by when you're working with the degrees. So in our problem, who had the larger degree, the top or the bottom? The bottom. So the bottom had the larger, which means that the top degree was smaller than the bottom degree, so where's my horizontal asymptote?
The 0.
0. Okay. You have 3 things to check. Those are the 3 things you check. So if the top is smaller than the bottom, if they are equal,
Wait, if the top exponent?
yeah, the degree. And that's what I'm saying. If the degree of the numerator is smaller than the degree of the denominator, or are the degrees the same?
So the M is the top.
Degree. So in our example here, the m value was 1, the n value was 2. Degree of the top is 1, degree of the bottom is 2. Does that make sense?
Yeah.
To get the vertical asymptote, let me put this on the line. Or excuse me, the horizontal asymptote. You're checking degrees. Numerator degree smaller than denominator degree. Does that make sense how I wrote that? If it's smaller than the denominator's degree, you have the asymptote at y equals 0. If the numerator degree equals the denominator degree, then it was y equals the coefficients. Yeah, correct. So, example like that, ours here, if you had 3x squared over 2x squared.
Can you just use the example?
Well, this one just falls in, because there's 3 possibilities. There's 3 possibilities for the horizontal asymptote. First one is y equals 0 if the degree of the top is smaller than the degree of the bottom. If they have the same degree, the asymptote occurs at their coefficients. So if it winds up being like 3x squared over 2x squared, the asymptote would be at y equals 3 over 2. Okay, that's what that would look like. Okay. No. What's that? Jack? What'd you say? I don't know if you had a question.
No.
This is weird because you responded to something. I thought you had a question. I want to make sure.
No.
Don't want to talk to you. And then the last one was if the numerator degree was greater than the denominator degree, then there was no horizontal asymptote. So there are 3 possibilities. All right, there's the 3 possibilities for that. Degree at the top is smaller than the degree at the bottom, then it's y equals 0. If the degrees are the same, it's y equals the coefficients. And if the degree at the top is bigger than the degree at the bottom, then there's no horizontal asymptote.
So, if they equal each other, the person would be 1.
Yeah, if in our example here, if this was f of x equals x squared plus 2 over x squared minus 5x plus 6, then you'd have y equals 1 would be your horizontal asymptote.
Okay.
That's all that means. It just means when the degrees are the same, it's just the leading term coefficients as a fraction. All right?
Okay. So,
And I remember this from last year. This was just nasty because you had all these different parts to worry about. Okay?
And I'm pretty sure we did this earlier.
we did
We did a little bit of
And
it
you wouldn't let us use our note card on the test.
because I know you had to remember some stuff.
Yeah, that's gonna happen again this time.
I- Okay. I-
Sydney.
So you had-
Sydney says no.
You guys worry too much. So you have these 3 possibilities to allow you to do all this stuff. And then you can go ahead and worry about finding domains and ranges and all that other junk. But for right now, let's just use this as an example to identify parts. this. We talked about that.
Like NNGs.
Yeah. 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 If you go back to it, the way that their book, as the pre-calc book wrote it, N and D is the same thing as the P and Q. It's just two different functions. This is just how they wrote it out. The graph has vertical asymptotes at the zeros of the denominator, horizontal asymptotes at one of those possibilities. They don't even tell you where your x-intercept is. At least I was kind enough to let you know that little bit of information. Every once in a while I have a decent idea. Okay?
I don't know.
Wow. Sure.
They'll hurt.
So let's do this. Let's find all the little bits of information. We're not going to worry about graphing it yet. Let's just get all the information we can. Where are the asymptotes? What are the intercepts? And try that. So first one we have f of x is 2x squared over x squared minus 1. And we're going to get the horizontal and vertical asymptotes. So where are horizontal asymptotes?
They're equal. So it'd be 2 and 1.
Correct.
Yes.
In this case here, the degrees are the same. So your horizontal asymptote is going to be at y equals 2. Since we're both squared.
Are we going to deal with
Well, we already did. Oh, you mean in these two sections? I don't know if they come up a lot.
Okay, because like you say, that was plus one. That's squared by plus one.
Yes. Yeah, these things are, I think we're going to deal with just reals for these. I think most of these are reals. We don't graph imaginaries.
Oh, we can.
We can. It's just, I'm thinking about it right now.
Don't do it.
I like the color of your shirt.
He's thinking.
Imaginary numbers. I'm doing it right now. Because it's imaginary. It's in imagination. It's in my brain.
Canarian.
You're so literal, man. It's okay. I'm just messing with you. There is a way to do it. We don't know. I'm just messing with you because imaginary numbers are imaginary. It's losing it now that I'm explaining it.
I think it's funnier when you go with this. So, I complimented your shirt.
Thank you.
What's the color? Coral.
I don't know.
He's a boy. He doesn't know.
Pinkish.
No, it's not pink, it's more orange.
Sorry. So we know the horizontal asymptote in this case is going to have to wind up at y equals 2 because the degrees are the same. Where are your vertical asymptotes? Vertical asymptotes are going to be where? Plus and minus 1. Very good. Okay. Same thing here. The horizontal asymptotes for the second one. Where's the horizontal asymptote going to occur on that one? F of x is x squared plus x minus 2 over x squared minus x minus 6. Where's it at? 1. Good. Horizontal asymptote here is going to be at 1, y equals 1, because they have the exact same degree. So it's just a fraction of their coefficients. So it's going to be at y equals 1. Vertical asymptotes, well, I have to factor the bottom. So it's wind up at x minus 3, x plus 2 when you factor it. Vertical asymptotes at 3 negative 2. So when do me a favor, when you guys are writing these things out, remember, you're writing equations of lines here. When you're writing equations of lines, it's not horizontal asymptote at 3. Well, horizontal asymptote would be y equals 3. Same thing with a vertical asymptote. It's always going to be x equals because it's vertical. Okay? Don't forget. Forget. Whatever. Let's see, I don't know how much further. Okay, domain. Let's look at real basic graphing of 1. And we're talking about domain. Which one is domain? Is that the x values or y values? It's the x values, and why do we know that?
We just do. X equals 3. Domain.
Because the alphabet, remember, domain comes before range,
Well,
x
I
comes
didn't know
before
that's what
y.
you were meant.
That's what I meant. You should know
I
these
thought it
things.
was like a trick question, like you meant like why do we domain?
So, do we have any x-intercepts?
3.
No. We don't have any x-intercepts here because there are no zeros of the numerator. We'll check our horizontal. Horizontal asymptote, what's the degree of the numerator? Well, it's pretty easy. Who wins, top or bottom? Bottom one. So when the bottom one has the larger of the 2 degrees,
Somebody at the door.
hey! It's like you knew.
You dust them.
How do you?
You know, we haven't been told that today.
What hour is this?
8,
6 or 7?
at least. Have a good one.
You too, buddy. Bless you.
Buddy.
Since the bottom has the larger of the degree, where's the asymptote? No, they're right. They're right. Oh, did I give you hers? Oh. Sorry. Jennifer, whatever. It is. Sorry.
Come on, Mr.
I'm old. Anyway, since the degree in the bottom is greater than the degree on the top, there are no horizontal asymptotes. Where's the vertical asymptote? Maybe there's a 2. Okay. How do I write that?
Y equals X equals 2.
Thank you, sir. X equals 2. So now we go to look at our graph. I know that happens. Which means I'm going to pick values on both the left hand and the right hand side of that. All right. So we'll use 1, 0, -1, -2. If I use 1, I get 3 over -1. 3. If I use 0, I get 3 over -2. 3 over -2. If I use -1, well, what's -1 minus 2? So what's 3 divided by -3? -1. And then if I use -4, excuse me, -2, I get -4 on the bottom, which gives me -3/4. So going on the other side, 1, -3, 0, 1.5, -1, -1, 2. So now you're getting the idea of this curve is probably doing this. And then go to the other side. Where we at 2, so use 3, 4, and 5. Might as well use 6 and use 3 in there. What's 3 minus 2? I'm checking on the right-hand side of the asymptote. So I get 3 and 3. 4 minus 2 is 2, so I get 3 over 2. 5 minus 2 is 3, so I get 1. And then this is 3/4. Okay. I have no idea what she said, but she said something someone else said that someone else said that she said. That was awesome. I'm done. Seriously.
Did that like you got that other.
Did you catch it?
I'm saying losing it.
Devin, there's a quiz on this tomorrow. She just went. I know. I feel
You
really
did this to me
bad.
last year. I had to watch one when I was sick and my face was all over.
It's doing that. You guys get the idea of how we're gonna plot through on these things, right? Really, really straightforward.
I was wondering if he was gonna say anything about it.
Domain.
He's talking so fast. I don't think I can talk that fast.
What's the domain?
I'm gonna watch this tonight.
Can all real numbers accept?
3.
3.
Oh.
Oh, sorry, 2. Yeah. Sorry, she overpowered you with the 3.
Chandler,
So yes,
was
your
that you
domain
again? Oh.
is all real, where x is not equal to 2.
Wait, why is it not? Oh.
Because the asymptote. Okay. Pretty much, unless there is universal classes, but. All right. Now we will also have, eventually we get to this more tomorrow. There will be times that you're going to have a non-continuous curve. What happens is that you can get a hole in a graph as things are being graphed through because you can have multiples when you're factoring. So this is enough for what you have for day 1. I'm just going to stop. I think this is pretty simple to start off on. We'll build up a little bit more on this for the day 2 stuff. The day 2 stuff, we'll talk about the holes, and we might get into a little bit of the slant asymptote. We might not. And then we'll get into the slant asymptotes then on Thursday. Hey.
In the grade book, it says that I didn't turn in my day 1 thinking, and I did, and I gave them back to me, but.
Then I will look and I will
But it
think.
wasn't like.
Oh, my dad put them in there, that's why.
Oh, maybe. 'Cause I
I'll look.
had an action site, but I had an F. And I was like,
I'll look at it. I never screw things
Mr.
up.
Murphy, I'm not gonna be here tomorrow.
I'm very sad. So, like I said, you got enough information for your day 1. Heck, you can probably get through most of the day 2 stuff if you read up on how to do the asymptotes. They're really easy to work on. So, go ahead and start working. I'll give you a little bit of time.